Hello everyone. Let us do our first experiment of the course, which is sampling of continuous time signals in time domain. We all know that if we consider x sub c t a continuous time signal, then how to convert this continuous time signal into a discrete signal is just by replacing this small t with n of capital Ts, where capital Ts is the sampling period and n is any integer type. Now let us see the same process in the form of a diagram where xct is a continuous time signal considered, and it is passed on to the sampling block to a sampler, which converts a continuous time signal to a discrete signal, and we get xn, which is the discrete signal, as an output, and this is obtained by replacing small t into the continuous time signal by n capital T sub s, where n belongs to any integer value and Ts is the sampling period. Now let us consider the operation of the sampling using this sinusoidal signal, where the time period of the sinusoidal signal is capital T. T by 2 is the half period of the sine wave. Now, to understand the sampling operation, let us consider the sampling period equal to one sixth of the time period. So that means if this is the origin, and from this point to this point is our period of the sine wave, and we will consider 6 samples in between this time period. So that means this will be first sample, second sample, third sample, fourth sample, fifth sample, and this is the sixth sample. And this point will belong to the next cycle. So that means 6 samples are taken in one period. That's what is the importance of this sampling period. So therefore, xn xn will be a discrete sequence, right? If you consider from this point, this is a b c d e f and G is my origin, Hij. So what happens is xn becomes a discrete sequence, sampling of the which represents the sampling of the sine signal. So if you plot the discrete sequence in this graph, if you see xn is the discrete sequence and n is an integer value. So this is 0, 1, 2, 3 up to 6 and minus 1, 2 on the negative axis. So these are the sample values. So this is the representation of the digital signal obtained from sampling the sine signal. Okay, let us now consider an example in which the continuous time signal is given as cos 2 pi t. So if you see the signal, you will see that f is equal to 1. That means the frequency is 1. The sample the given continuous time signal with sampling period. The sampling period given is 1 by 8 seconds, and obtain the digital signal. How can we get? So if this is the continuous time signal, then that means the frequency is 1 hertz. That means the period of this signal is 1 second. The sampling operation for this signal with 1 by t sampling period as 1 by t seconds will be performed like this. This is my signal cos to pi t, where I have to replace small t with n capital T sub s. So therefore xn will be, so if I replace with nts, so it will take 2 pi n divided by 8. So my resultant digital signal will be cos pi n by 4. Now we know that if sampling frequency given is 1000 hertz, that means 1000 samples are collected per second. So that's the meaning of sampling frequency. And this is important because TS is the if TS is the sampling period and capital T is the period of the sine wave, then how many we want to know that how many samples are present in this period, because this if Ts is the sampling period, so that means Ts, if Ts is the time, then one sample is there, and if capital T is the time, then T by Ts will be the number of samples present in one period. One period means the period of the sine wave. And we can calculate the number of samples from here in one period of the sine wave. Now, this is the period of the signal, the continuous time. So this is just the other kind of information related to the time period. So if you divide t by ts by this 1 by t, so you will get the sampling frequency back, which is the reciprocal of the sampling period. Now, these are some more examples given. The continuous time signal given is cos 2 pi ft, where f is 1 kilohertz with a sampling frequency of 16 kilohertz. And we need to sample it. According to the given information, we need to find the number of samples taken from one period of the continuous time signal. So that means we have to use the formula. That means if t is the sampling period, t is the sampling period, then it is equal to the reciprocal of the frequency of the signal, which is given as 1 kilohertz. So 1 millisecond will be the time period. So 1 millisecond, and what is the sampling frequency given? Sampling frequency given is 16 kilohertz. 16,000 multiplied by 1 millisecond will give me 16 samples. So what are these 16 samples? These 16 samples are present in one period of the sine wave, right? By using this formula, because this will be equal to capital T into 1 by Ts. 1 by Ts is the frequency, sampling frequency. So capital T multiplied by the sampling frequency will give me the number of samples. So that's what exactly is done here. So whatever we have covered previously is basic information related to the sampling process. Now let us look at how to code for the sampling operation using MATLAB. So the problem given at hand is we have to use MATLAB and draw the sine signal first of all, whose period is 1 by 4, and we have to use time interval between 0 to 2. These are the time steps for your drawing. So first thing we need to do is to draw the sine wave with this period. Now to start with, because the time the range of the time given is from 0 to 2, we have to draw the signal. So we need to generate a time vector with the 1 by 1000 steps going from 0 to 2. So that's what if we will write this code, this will generate a time vector with step size equal to 1 by 1000 going from 0 to 2, which is between this interval. Now in the next step, using the, so this is the formula of the mathematical expression of generating the sine wave, where the frequency, if the period is 1 by 4, so that means the frequency of the signal will be 4. So what we do is we declare this time vector. We declare f as a variable which is equal to 4. Basically this is the frequency, and this sine signal we define like this: sine of 2 pi ft. All right. Now this is the time vector, frequency, the signal defined. Now we need to plot the signal. We can plot the signal in MATLAB by plot t, which will be on the x-axis, and xt. T will be, these will be the steps that will be coming onto the x-axis, and the sine wave will be generated starting from the 0 in the time axis, right? X label will label this x-axis with the t, y label will label this axis as sine 8, slash pi will put pi here, t. This is how the labeling is to be done. Title of the graph is sine 8 pi t. So that's the title, how you can define the title of the, so this is the sine drawing of the sine wave using MATLAB. Now we have to sample this sine wave. So sample the sine wave with period 1 by 4. So exactly the same specifications are given. We need to sample the sine wave with a period of 1 by 16 and obtain the digital signal and plot it. Let's see how to do this. So this is the sine wave generation. This is now what is the sampling period given? Sampling period given is 1 by 16. So we create a sampling the step size corresponding to the sampling period between time interval from 0 to 2. So TS uh, will be starting from 0 going to 2, and this will be the step size corresponding to the sampling period. Okay, now let us look at the plotting of the graph for this sampling period of 1 by 16, because we have already created these discrete time steps from 0 to 2. This is the interval, and TS is the sampling period, because we need to create these steps of this size. Now, because we have to draw the continuous time signal and the discrete time signals both, so in that case, these are the initial steps only. What we have done here is the discrete signal, and because in the continuous time signal, it will come t here, and in the discrete signal, because we need to show the sampled version of the signal with this sampling period, so ts will come instead of t. So up till here, now we need to plot these two signals. We will use the plot command, plot t comma x underscore t. This will plot the continuous time signal, because plot will help in plotting the continuous time signal. Hold on will retain this graph, and stem is used in MATLAB to plot the discrete signal, where ts is the discrete sequence along the x-axis, and xn is your signal defined here, which is the digital signal or the discrete signal. Red is the color of the signal, and filled is the, because you will get the circles there at the endpoints. Now this is, if you run the code, you will see this is your continuous time signal. Mind it, this is not the discrete signal. These do not confuse with these dots as the discrete signal. This is the continuous time signal, and if you run the graph, if you run the code here with your stem command, now you will see the discrete signal. Now uh, these are the sample values that you will get in the discrete signal. Now let us take the sampling period as 1 by 64. Here the sampling period is defined as 1 by 64. Accordingly, the time vector will be created for the discrete sequence. And if you plot now this graph with stem command, you will get these. This is the discrete signal that you will get.